Hello everyone, let's look at this equation here. This time we have a trig equation with one of the functions whose argument is not just x. So for this function sine, here we have 2x in there. In general, this is harder to work with when the arguments are not the same for the trig functions, because even if we can turn one into the other, then we will still have a lot more things that we need to worry about. So in this case, we would use identity to rewrite this sine 2x into an expression that will involve either sine or cosine or both that has an argument of x. And so in this case, we have two ways to do it. One way is to use a sum formula by writing the 2x as x plus x, then we can expand it from there, or we can use the double angle formula. And the faster way, of course, would be to use the double angle formula. It's actually easier as long as you remember the formula. And so let's just write it down right now. So the double angle formula. Okay, so the double angle formula would be this one. So it would be sine of 2. And then the data, right? So we have the sine of 2 data. That's equal to 2 sine and then data. And then cosine data. Okay, so see that as you can see here in the argument, we have 2 data in the original expression, but once we write it in the expression on the right hand side of this equation, then we actually will have just the data in there. And so we can actually rewrite this one so that it will turn into sine. Actually, we will turn into 2 sine data. In this case, it will be x. So 2 sine x cosine x, and that's equal to cosine x. So when we get to this step, it's so easy that because we see a cosine x on both sides, it's so easy that we are just going to cancel them by just dividing cosine x from both sides, right? But the problem of doing it this way is that if you're dividing by cosine x, you're assuming that cosine x is non-zero. But what if cosine x is equal to 0? Then it will cause problem. It's really just saying that, okay, we're not considering the case when cosine x is equal to 0. But if cosine x is equal to 0, then it will actually give us some solutions to this equation, right? So it's not a good idea to do it this way. If you really want to do it this way by crossing out the cosine x, that's also okay, but you also would need to write down a separate case where cosine x is equal to 0 so that we will solve that equation for the solutions for this equation. But it's easy to forget. So another way to do it, right, which is actually giving you the same thing, is that you are just going to move everything to one side of the equation, and you're just gonna keep 0 on the right hand side, right? So let's do that. Let's subtract cosine x from both sides. And if we do that, then we are going to get 2 sine x cosine x minus cosine x, and that's equal to 0. So in this case, what's happening here, we can factor, and we see that cosine x is a common factor for both terms. So if we factor it out, so let's try factoring it out. Then if we factor out the cosine x, then you are going to get what? We are going to get 2 sine x minus 1. And that's equal to 0. So now this expression on the left hand side of the equation is already factored. So we can start breaking it into 2 cases and then start solving the equation. So what we can do is that we can set the cosine x, right, this green cosine x, and set it equal to 0, or the 2 sine x minus 1 is equal to 0. So now we can break it into 2 cases. Then now let's consider. for this cosine x being equal to 0, because that's this 0 right here tells us that will be a quadrantal angle. So in this case, we are going to just draw the xy plane and then see where the points are, right? So let's just write this. Let's just draw the xy plane quickly. Now, what's going on here is this. We have 2 points that will that will give you a 0 for the cosine x, which is this point here, because we have 0, 1, right? And then the other point, it's down here, which is 0, negative 1. And remember that this x value of the point will give you the cosine x, right? And so in this case, both are getting 0. So one of the points would be this point at the top, and the positive y-axis is the pi over 2, and the other one is actually the 3 pi over 2. Okay, so now the solution, what are the solutions? The solutions that will give you 0 from the cosine would be, so x will be equal to pi over 2 or 3 pi over 2. Okay, so that's that one. And what about this one? This one we actually need to isolate the sine function, so that will be straightforward. So we add 1 to both sides of the equation. We are going to get 2 sine x is equal to 1. And then you divide both sides by 2, then you are going to get sine x is equal to 1 over 2. And just like usual, we are going to just draw the triangle. And so our right triangle will actually be, if you memorize the values, then you actually don't even need to do this, right? Because the 1/2 tell you that the reference angle would be 30 degree, but I'm just drawing it to show it. So sine is the opposite over the hypotenuse, and then the adjacent is square root of 3. And as we all know, the the opposite side that's facing the angle that we are considering would be 30 degree, because it's facing the 1. So now we can see that our reference angle would actually be 30 degrees, so that would be pi over 6. And then what about the quadrants? The quadrants are 1 and 2, because sine is positive. So quadrants are 1 and 2. So once we have that information, we can write down the solution. The solution would be, the one in quadrant 1 is the same thing as the reference angle, so we are going to get pi over 6. The other one is the one in quadrant 2, so that will be 5 pi over 6. What are those angles in degrees? The first one is 30 degree, as you know. The other one is 180 minus the 30, which is 150. So 150 degrees. Okay, so we are getting 4 solutions in this equation. We have pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. Yeah, so in general, when the argument is not just always x throughout the whole equation, then we probably need to use some identity to turn the equation for solving the equation. Okay, yeah, so that's it for this video. If you like my video, please subscribe to my channel and then give me some support. It will help the channel grow, and then so that I can make more videos. Yeah, so thank you for watching, and I will see you next time.